Hello students, welcome to YourPedia Education. Today we are going to solve the NPTEL assignment question for the subject of irrigation engineering, and the question is question number 8 and it is present on the page number 300 of this particular book. Okay, so let us just read the question and try and solve it. So the question is, we have been given a 30 centimeter diameter well which is being pumped at a rate of 1360 liters per minute. Okay, this is our main well, this is its diameter. Measurement in the nearby test well. So these two are the test wells which are at some distance from the main well. It is at a distance of 6 meters and the second test well is at a distance of 15 meters from the main well. At a distance of 6 meters, the well being pumped, the drawdown was 6 meter. So the initial groundwater level was here, okay, was here, which is at a distance of 90 meter from the base of these wells. But after pumping for a given amount of time, the drawdown in this particular test well was 6 meter and in this well was 1.5 meter. So this is my H1 value, this is my H2 value, and H value is my total depth or the initial depth of groundwater table from the base of the well. Okay, and since here the groundwater table word is used, therefore what kind of aquifer is this? Is unconfined aquifer. Otherwise, in case of your confined aquifer, there is no groundwater table. In that case, the water rises to the top surface of the aquifer, and if a well is being made, in that case the water may rise above the top surface of the aquifer also, and the line joining the or the surface joining the topmost points of those wells will give me the piezometric surface. So since here groundwater table word has been used, iska matlab hai ki it is an unconfined aquifer and the formulas related to unconfined aquifer will be used here. Okay. Now the next is the next thing, we have to find the coefficient of permeability, first thing. Second thing, we have to find the drawdown in the well, in the main well due to pumping. Drawdown in these wells already given, but is main well mein kitna drawdown hua, that we need to find out. Okay, this is the drawdown and this is the HW value. And third thing that we need to find is what is the maximum rate at which water can be pumped out of this particular aquifer, and we have to take the radius of influence as 150 meters. So let's just move on to the first question, जिसमें हम लोग निकालेंगे the coefficient of permeability. We know that the formula in case of unconfined aquifer is pi k h2 square minus h1 square divided by natural log of r2 by r1. Now h2 and h1 are basically the distances from the base of the aquifer to the water levels in that particular well. So in this case it is coming out to be 84, in this case is coming out to be 88.5, and this are R2 and R1 are the distances of these wells from the main well. So by putting all these values, I get the K value as, now my Q is basically my yield that I'm getting from main well, and this yield was given in liters per minute, but I converted it into meter cube per second in the SI units. And when I substituted the value, I get the value of coefficient of permeability as 3.492 into 10 to the power minus 6 meter per second. Okay, so this much coefficient of permeability was there. Now in the next part, we need to find out what will be the drawdown in the main well. We need to find the value of HW. If we find the value of HW, then this HW, if I calculate, then drawdown I can calculate by subtracting the HW from 90 meters, which was the initial level of the groundwater table. Now this HW ke liye there is a formula that's called Dupett's formula, and that formula is this, pi k h square minus HW square divided by natural log of capital R by RW, where RW is the radius of the main well, capital R is the radius of influence that has been given as 150 meter. Okay, this is the radius of the cone of depression. Radius of influence is the cone of this is the cone of depression, and then h square is the initial height of the groundwater table from the base of the aquifer, and HW is the final height. Okay. So by putting the values h as 90 meters and HW, I'm just putting HW only, and R value is 150 meters. Radius of the well, the diameter of the well is 30 centimeters, so the radius of the well will come out to be 0.15 meter. So putting all these values, I get the HW value as 47.41 meter. If HW is 47.41, this is 47.41, then what will be the drawdown? 90 minus 47.41, which is coming out to be 42.58 meter around. So this will be drawdown in my main well. Third part is what is the maximum rate at which the water can be pumped. So how can we find the maximum rate at which water can be pumped? For that case, I will put the drawdown as the maximum. Okay, if I put, in this case, my drawdown was coming out to be something 40 point something, 42 meter or something, and then I was getting a yield of this much. If I want the maximum yield, I can I can go up to, since this level will reach the bottom. जब तक ये level पानी का level bottom तक पहुंच सकता है, मैं पंप आउट कर सकता हूं. अगर इससे नीचे चला गया, then pumping out at higher rate is not possible. So maximum rate that is possible will come when the drawdown is maximum, when the drawdown is equal to the depth of the aquifer, or the drawdown is equal to 90 meters. So जब drawdown 90 meters होगा, तो what will the value of HW? 0 meter. So if I put the value of HW as 0 meter in the Dupit's formula, I can find the maximum yield or the maximum discharge that is possible out of this aquifer. And for that value, I'm just putting HW as 0, and I get Q max as 0.0312 meter cube per second, or in terms of liter per second, it is 1877 liter per minute. So I can also write in this formula also. So this was about the maximum discharge that we can get from this particular aquifer. Now the next thing is, yes, so this was your question. I hope you must have understood this question. If you want to go through it again, it's up to you. If you have any doubt or query, you can write to us and we'll try to solve it as soon as possible. Thank you very much.